Hi everyone, today we're going to take a look at our Unit 3 self-assessment. If you are in Cohort B, then you're having your Unit 3 math quiz this week on Friday, and if you are in Cohort A, then your Unit 3 math quiz will be on Monday. Let's go ahead and take a look at the self-assessment. There are practice problems on the right, and then there are skills listed on the left. If you feel confident with the problems on the right, you can put a check mark in that box. Let's take a look at question number 1. This is a story that we have to solve with a division model. So it says Joey and his 3 friends went on a camping trip. They brought 7 graham crackers to make s'mores. He wants to share them evenly with all of his friends. How many graham crackers can each friend have? The first question that's going through my mind right now is, can everybody get at least 1 full graham cracker? I have 4 friends and I have 7 graham crackers. Yeah, everybody can have at least 1 graham cracker. So I know that when I'm done, my answer should be an answer greater than 1. If I get a fraction for my answer, I know that I've done something wrong. I'm going to start with my visual model. I'm just going to quickly draw 7 graham crackers. I'm going to imagine these 4 friends. I'm just going to think of them as numbers, person 1, 2, 3, and 4. I'm going to start passing out full-size graham crackers, 1, 2, 3, 4. And then these last graham crackers are going to be broken up. I'm just going to cut each one into fourths just to make it easier for me to see. And I'm just going to imagine 1 piece of this cracker going to person 1, person 2, person 3, person 4, and so on and so on. So I can see that each person is getting their own cracker and then a little piece of those last 3. I want to think about my solution. I want to think about what my division problem is here. What is it that I'm dividing? I'm dividing crackers by the people. It's what I have divided by who I'm sharing with. So I have 7 crackers divided by 4 friends. Remember that division problems are just waiting to be turned into fractions. That division symbol is waiting for a numerator and it's waiting for a denominator. So 7 divided by 4 is really just 7 divided by 4. Now that's an improper fraction, 7/4. I can go ahead and set up division, or I can use mental math to figure it out. If I set up a division box, which of these numbers goes inside the box? It's the 7 because the top number hops into the box. I like to say the top hops. So over here, I can imagine this division problem. 4 goes into 7 one time, and I'm left with a remainder of 3. I don't want to say 1R3 anymore. I want to use a fraction. So what is my final answer? How many graham crackers can each friend have? That's right. They can have 1 3/4 crackers. All right, let's take a look at number 2. This time, we're talking about Matthew, and he has ordered 2 pizzas to share with his family on movie night. There's my 2 pizzas. If there are 3 people in his family, what fraction of a pizza can each person have? So again, I'm asking myself, 2 pizzas, 3 people. Can everyone just get a pizza? Am I just handing out full-size pizzas today? No, I can't. I won't have enough. So I know my answer should be a fraction. What is it that I'm dividing? What do I have divided by who I'm sharing with? That's right. I have 2 pizzas divided by 3 people. I'm going to go back to my visual model and I'm just going to cut those pizzas. Maybe this part of the pizza is for Matthew. Maybe that's just cheese pizza. Maybe this one's pepperoni. So Matthew's going to take a piece over here. Maybe this over here is for his mom. This is for his dad. Okay, and I can see the portion that each person gets. Remember that this division problem is just waiting to turn into a fraction. 2 divided by 3, 2 divided by 3. So what is my final answer? Each person will get 2/3 of a pizza. If you felt confident in those problems, hopefully you put a nice check mark on the left. All right, let's turn the page. This time we're going to be doing division number stories, but we're going to be interpreting the remainder. We have 3 choices for interpreting the remainder. Do you remember what they are? We can ignore the remainder, we can round up our quotient, or we can actually report out as a fraction now. Let's see what makes the most sense in this problem. It says Liliana is packing 126 winter hats into donation boxes. 19 hats will fit in a box. How many boxes does she need? So I'm thinking about what I have. I have hats, and I'm thinking about how I'm sharing them. I'm putting them into these boxes. So my math problem here is going to be 126 hats divided into boxes of 19. Okay, now this long division is going to take a little bit of work because 19 does not go into 1 and 19 does not go into 12, but it does go into 126. So off to the side, you should have some scrap work. Maybe you tried 19 times 4, 19 times 5, 19 times 6, 19 times 7 before you were able to figure out the answer. How many times does 19 go into 126? It goes in 6 times. What is 6 times 19? It should be 114. When I subtract, I get a remainder of 12. That 12 is extra hats that didn't fit into a box. So let's see if we can work through some of these answers. I'm actually going to start with my number model because I already know what it was. I did 126 divided by 19 equals H for hats. That leftover is hats. I'm trying to make a donation. So I have options with this remainder. I can just ignore it and I guess just get rid of the hats, which sounds awkward because I'm supposed to be making a donation, which is a nice thing and I wouldn't want to be wasteful. I could report as a fraction and I could like find another box and kind of like rip it up and just use the part of it that I need. Or I could round up the quotient and I could just get another box. It's not going to be full, but at least I'd be able to donate all the hats. What is the best option for my remainder? Yeah, I think we should round the quotient up. So instead of getting 6 boxes, I'm actually going to make sure that I get 7 boxes. What did you do with your remainder? Well, you already told me that you rounded up the quotient. I'd like you to give me a reason why. Hopefully you said something about making sure that we could donate all of the hats and that they could all fit into a box. All right, let's take a look at the next question. We're going to be interpreting the remainder again. This time it says Nina had 11 apples to share with 3 of her friends. If all 4 people get an equal share, how many apples will each person get? Pay attention to these numbers here. We have 11 apples. It says Nina and her 3 friends. I'm just going to ignore that 3 though, because I know it's actually 4 people that I'm dealing with. 11 apples, 4 people. So let's think about how this is going to work out. I'm going to be solving the problem of 11 apples divided by 4 friends. This feels like mental math. I think we can do it quickly. How many times does 4 go into 11? It goes in twice. 4 times 2 is 8, and we're left with 3. All right, so I want to think about what I'm supposed to do with that remainder. Remember that it's an apple. Those are apples that are left over. We talk a lot about sharing with food. Let's see how this works out. My number model is 11 divided by 4. What do you think I should do with that remainder? Should I just throw those 3 apples away? Should I wait around and hope that a magical apple appears and we can all have one? Or should I just start slicing the apples? I think we can interpret this one as a fraction. So my solution, I'm going to take this answer. I know I can have 2 apples. This remainder 3, I'm going to turn it into a fraction. Remember that what you were dividing by in the first place becomes your denominator. So I have 2 3/4 apples. What did you do with your remainder and why? Hopefully you said something about how it's easy to share apples, and that's why we interpret it as a fraction. If those 2 problems went well for you, hopefully you put a check in that box. Let's go ahead and turn to the next page. We have one more interpreting the remainder question. This time we're talking about money. It says Samantha had $23 to spend at the store. She wanted to buy socks that cost $3 per pair. How many pairs of socks can Samantha buy? All right, so let's start with our division. I have money, and I know the total cost. So I'm going to take that $23 that I have and divide it up into groups of 3. Again, this feels like mental math. How many times does 3 go into 23? It goes in 7 times. 3 times 7 is 21, and I'm left with 2. What is that 2? Is it 2 Samantha's, 2 stores, $2, 2 socks? It's an extra $2. So I need to think about what to do with that money. Should I just ignore it and keep that money in my pocket? Should I use that money to buy like maybe a part of a pair of socks? Or should I hope for magic money and hope that they'll give me the socks for less than they actually cost? Yeah, I don't think we can buy partial socks, and they're definitely not giving them to us for a lower price. That doesn't happen. So let's take a look at our number model. We did 23 divided by 3 equals socks. I got 7 with a remainder. I have to just ignore it. I know I can buy 7 pairs of socks. I'd like you to write a sentence telling me what you did with your remainder and why. Hopefully you said something about how that remainder was not enough to get an extra pair. All right, let's take a look at the next section. This is going back between mixed numbers and improper fractions. Remember that the fraction bar is just telling us to divide. So right here where I see 12/5, it's really just 12 divided by 5. If that's mental math for you, great. If it's not, then somewhere in your notebook or on this paper, you should have set up, remember the top hops in the box, 12 divided by 5. You should have set up 42 divided by 12. You should have set up 98 divided by 6. Okay, what did you get for the first one? What is 12/5? It should be 2 2/5. What is 42/12? There's really a couple of good answers here. You probably got 3 6/12 originally, but that would also equal 3 1/2. And how about 98/6? That one was a big one. Your answer should be 16 2/6. Some of you might have also figured out that that is 16 1/3. All right, down here at the bottom, this is the opposite. Now we have mixed numbers and we're going to turn them into improper fractions. Remember that there are a couple of steps. We multiply, we add, and our denominator always stays the same. So for this one, I do 6 times 5, that equals 30, plus 4 more is 34. Denominator stays the same. What did you get for 2 2/5? It should be 12/5. And what do you get for 8 3/4? It should be 35/4. If you felt confident with those skills, hopefully you can put a check in that box. All right, we're moving on to the very last page. A lot of this last page is review, stuff that we've been working on for a while, but was still pretty important in Unit 3. The first one, number 8, is a multiplication problem, and so is number 9. What did you get for problem number 8? Your answer should be 2,431. And how about number 9? Hopefully you got 19,362. We have a couple of long division problems here. Those should be set up in your notebook. The first one, you definitely should have had a remainder. What did you get for your answer? Number 10 should be 248 with a remainder of 3, but now that we know how to report as a fraction, the best way to say that would be 3/5. How about number 11? This one works out perfectly. You should have 520. I hope you feel confident with your multiplication and your division. All right, we're down to the last box. We've been looking at expressions and equations all year long. We have to remember how to solve these in the correct order. You always want to start with parentheses first. If you have parentheses and brackets, you just work your way from the inside out. So let's take a look at number 12. We're going to take care of those parentheses first. That's 6 times 3. And then we can add, and then we can subtract. What do you get for number 12? The answer there should be 20. Question number 13, we're going to start on the inside here. We're going to subtract, then we're going to add, and then we're going to multiply. What do you get for your final answer for number 13? Let's check it out. 5 minus 2 is 3. 10 plus 3 is 13. Multiply that by 4. You got 52. All right, the next one has 2 sets of parentheses. Solve each one, and then you'll multiply your answers together. What do you get for number 14? This one definitely took some extra scrap work to the side. You should have 255. All right, for the last one, take care of those parentheses, divide, and then add. What do you get for number 15? Your final answer should be 10. If you got those problems correct and you feel confident evaluating those expressions, you can go ahead and put a check in the box. All right, don't forget, if you're cohort B, your math test is coming up on Friday. If you are cohort A, your math test is coming up on Monday. I wish you the best of luck, and if I don't see you, I hope that you have a wonderful Christmas break.